Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 2 of a 4-part series on algebraic functions for mathematics grade 10, and that is the quadratic function, otherwise known as the parabola. In part 1, we focused on the straight line graph, and in part 3, we're going to focus on the hyperbolic function, otherwise known as the hyperbola. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 3 of this series and more video uploads we make. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at functions of the form y equals to x squared, which is basically grade 9 revision. And if you didn't do this in grade 9, don't worry, I'm going to show you exactly how easy it is to draw this most basic parabola you'll ever come across. Number 2, we look at functions of the form y equals to ax²+q, which is basically that parabola, the basic one, but shifted about the y-axis. And we're going to look at the effect of q and the effect of a. Number 3, we're going to be discovering characteristics, which is your domain, your range, your turning point, and so on and so forth. And number 4, we're going to look at example 1, which illustrates how you figure out what the characteristics look like. Number 5, we're going to be sketching functions of the form y equals to ax²+q. And number 6, we're going to look at examples 2 to 6, which basically showcase how you deal with different problems connected to the parabola and how you interpret the parabola in a question. We have a lot to cover, so let's start. As promised, we're going to look at functions of the form y equals to x squared, which is the most basic unit parabola you will ever come across. Now, we're given a table that we need to fill with the function y equals to fx equals to x squared, and we're given x values that we need to put into the function so we can figure out what their corresponding y values are, so that we can take those points and plot them on the Cartesian plane. Now let's do it. We know that f of x equals to x squared, so f of negative 2 equals to negative 2 all squared, which is equals to 4. So we'll write 4 over there. F of negative 1 equals to negative 1 all squared, which is equals to 1. We'll write 1 there. F of 0 equals to 0 all squared, which is equals to 0. So we'll write 0 right. F of 1 equals to 1 all squared, which is equals to 1. We'll write 1 there. F of 2 equals to 2 all squared, which is equals to 4. So we'll write 4 there. F of 3 equals to 3 all squared, which is equals to 9. So we write 9 there. Now we've got all these points sorted in a table. Now what we need to do is to plot them on a Cartesian plane. Now let's clean this table up first before we can do that. Now let's plot the points on a Cartesian plane. I already have a Cartesian plane prepared for us. Now we're plotting the graph of y equals to x squared using the points that we've just calculated. It's going to be a red graph, so let's change the color to red so it corresponds with the colors. When x equals to 0, we know that y equals to 0. So the point is going to be right there at the origin. 0, 0. When x is equals to 1, y equals to 1, so the next point is over there. When x is equals to 2, let's fix that. When x equals to 2, y equals to 4, so the point is right over there. 2 to 4. When x equals to 3, y equals to 9, so let's go over there, up there, and look for 9. 1, 2, 3, so that's the point where it is over there. On the left hand side, when x equals to negative 1, y is equals to 1. So negative 1, 1. When x is equals to negative 2, y equals to 4. There it is over there. When x is equals to negative 3, y equals to 9. So let's go up there and look for 9. So -1, -2, -3, that's where our 9 is, with the -3. Now let's join the points together. We've plotted the points, now let's join them together in a smooth line, a smooth curve, as smooth as we can. There is the curve that we're trying to draw. On the other side, there is the other side. Now let's look at what the graph calculator drew to see if we're on the right track. There, it is on the right track. There is the graph of y equals to x² according to the graph calculator. Now let's go back to the questions. The second question is like, we've joined the points with a smooth curve. Now, number 2 says the domain of f is x is an element of real numbers. Now, determine the range. The range is all your possible y values in the graph. Now, according to this graph, your y values go from 0 all the way to infinity. So, the answer is y is greater than or equal to 0. Now let's go back to the color. I'm not sure why this is not working. Okay, let's go back to the color. All right. So y is greater than or equal to 0 is the range. Number 3 goes, about which line is f symmetrical? Let's look at the calculator drawn graph. The line about y equals to x equals to 0, or the y-axis. So this graph is symmetrical about the line y equals to 0, x equals to 0, I mean. The y-axis. So it's about the line x equals to 0. Determine the value of x for which f of x equals to 6¼ Confirm your answer graphically. Now we're going to use the graph calculator so you can see exactly what we come across. Alright, so here we're going f of x, which is x², f of x, which is x², x² equals to 6¼ Take out a calculator. Therefore, x² equals to, take out a calculator and you go 6 times 4 plus 1 equals to, that will give you 25. So that's 25 over 4. 25 is the square of 5 and 4 is the square of 2. So that makes it easy for us to find our x. Our x equals to plus or minus square root of that, 25 over 4, which is equals to plus or minus 5 over 2, which is equals to 2½ Now, according to the graph, at 2½ we should be able to, let's try and draw a line. That's at 2½ 2½ is somewhere right there. So that's the line right there. Let's make it thicker and let's make it blue. Alright, now let's 2½ let's shift it to 2½ That's 1½ over there. 2½ Okay, let's zoom in. So yes, it is about at the line 6¼ which is over there. 6¼ which is right there. So yes, it does correspond. That's how you show that graphically. Let's go to the last question. The last question says, where does the graph cut the axis? Where does the graph cut the axis? The graph cuts the axis at the origin when x is equals to 0 and when y equals to 0. This is where it cuts the axis. When x equals to 0 and y equals to 0. In other words, at the origin. That is the point 0, 0. So now next we're looking at functions of the form y equals to ax² + q. Now let's look at the effect of q. When q is equals to 0, you've got your normal red graph which sits at the origin. But what happens when your q is equals to 1? The graph is shifted 1 unit up, and when q equals to 2, you get y equals to ax² + 2. You get the green graph which is shifted 2 units up. Now what happens when your q is negative? Your graph is shifted down by the q units that you're subtracting. So for y equals to x² - 1, the graph is shifted 1 unit down. That is the purple graph. And when x equals to y equals to x² - 2, your graph is shifted 2 units down. That is the black graph. Now let's look at the effect of A. The effect of A basically affects the shape in any type of graph, whether it's trigonometric or algebraic. Now what happens when A is positive? When A is positive, for example, in these three cases, the blue, red, and green graph, your arms look up. Positive A, arms look up. When the A is negative, your arms look down. Now what happens when your A is multiplied by a factor? For example, when A equals to 2 and you get y equals to 2x². What happens is that your graph now reaches milestones sooner. So where you had your y equals to 1, it is multiplied by 2 and it gives you 2. So it gives you a thinner graph that lies right inside the graph of y equals to x². Now what happens when you multiply that by a fraction, for example, 1/2? When A equals to 1/2, what happens is that your graph becomes wider because it reaches milestones a lot slower. What happens when your A is negative? Your graph looks down. Now y equals to -x² is exactly y equals to x², but just flipped upside down, looking down. That's the purple graph. Now the black graph is that same graph but multiplied by 2. So you get y equals to -2x². So it is thinner, still looks down because it is negative, but it is thinner than the graph of y equals to -x² because it has been multiplied by 2. So your graph reaches milestones sooner. Now let's look at the characteristics. Basically, your A tells you what the shape of the graph is going to be. If your A is positive, your arms look up, you have a smiley face graph. And when your A is negative, your arms look down and you have a frowny face graph. Now the domain is x is an element of real numbers. Does not change for all your quadratic functions. That's what the domain is going to be like. Now the range depends on what your A is. If your A is positive, the range is going to start from Q, including Q, and end at infinity because you have a local minimum turning point. When your A is negative, you have a maximum turning point. So you have a local maximum. What happens is that your range goes from negative infinity all the way to Q. Notice that it includes Q, so that's why you have a corner bracket there in front of Q, next to Q. The x and y intercepts don't change, they always will stay this way. If you're looking for your x-intercepts, you just make y 0. And to find the y-intercept, you make x 0 and solve, and you will get your intercepts. Now the turning point is simple, it's just 0q. Now let's look at example 1. If g of x equals to x² + 2, determine the domain and range of the function. The domain should be very, very easy. We just looked at the domain now. The domain for any function of a quadratic form in this case is x is an element of all real numbers. Domain, x is an element of real numbers. That's the domain. And the range depends on what your A looks like. What is the range? What is our A? Our A is equals to 1, which is greater than 0. So you have your arms looking up, meaning that you have a local minimum turning point. All right, so therefore, your range is Q and positive infinity. That's your range, or you can just go y is greater than or equals to q. That's another way of writing the range. Example 2 goes, sketch the graph of y equals to 2x squared minus 4. Mark the intercepts and turning points. Step number 1, find the shape. What is your A? Your A is equals to 2, which is greater than 0, right? Therefore, you've got your arms looking up. The turning point, you have a maximum and minimum turning point over here, so we're going to start with your Q. So the turning point is 0Q. Sorry. The turning point is 0Q. 0Q. And that point is 0, negative 4. Okay, now let's find the x-intercept. X-intercept, you make y 0. Therefore, 0 is equal to 2x squared minus 4. Therefore, take 4 to the left-hand side. 4 equals to 2x squared. You divide both sides by 2. You end up with 2 on the negative side divided by 2 on the right-hand side. That gives you 2 equals to x squared. Therefore, x is plus or minus square root of 2, which is basically, take out a calculator, square root of 2, which is basically equals to 1,41, which is approximately 1,41. That's approximately what the x-intercept is. Now the y-intercept, you make x 0. Therefore, y equals to 2 in brackets 0 all squared minus 4. Therefore, that is equals to 0 minus 4, which is equals to negative 4. So your y-intercept is the point 0, negative 4. Notice that your y-intercept and your turning point are the same point in this case. It won't always be like this, especially in grade 11 when you look at the shift from left to right included in the equation as well. But for this grade, that's all you need to know. Now let's plot this point on the Cartesian plane. Right, let's plot the points first. We got that the turning point is 0, negative 4. 0, negative 4 is the turning point. 0, negative 4. That is the turning point. Let's make this blue. 0, negative 4 is the turning point. That's the turning point. And the x-intercepts are negative 1,41. So that's somewhere between 1 and 0. 1 and 2. So that's there. And then let's figure out what happens when your y equals to 2. When your x equals to 2. Y equals to, let's reduce this. Y equals to 2 all squared minus 4. So that is equals to 2 times 4 minus 4, which is equals to 8 minus 4, which is equals to 4. Same thing with when x is equals to negative 2. 2 in bracket negative 2 all squared minus 4. Negative 2 all squared is 4 minus 4. So that is 8 minus 4, which is equals to 4. So on either side, when x is equals to 2 and when x is equals to negative 2, your y value is 4. Let's plot that point. When x is equals to 2, our y value, and negative 2, our y value is 4. So that's the point there. That's the point there. And that's the point on the other side. Alright, now before we plot this graph, let's plot the other graph of y equals to x squared. The standard one. The basic one, not the standard one, the basic one. So we can compare it with this new one. We've already drawn the important milestones for this one, so let's draw the other one. The other one is very simple. It goes from 0 to 1. Okay, so when x is equals to 0, y equals to 0. When x is equals to 1, y equals to 1 on either side. When x is equals to 2, y equals to 4. Y equals to 4 on either side. And then when x is equals to, notice how these points coincide with each other. I want to leave a bit of color so you can see what happens here. Alright, now let's join the points for the basic y equals to x squared graph. Joining the points. Notice that you don't have to draw this y equals to x squared graph. It's not part of the question. I'm drawing it so that you can see how it compares with the one that we're drawing now. Alright, let's draw the blue one. Let's join the points of the blue one. On the other hand, let me fix that. Now let's look at what the graph calculator calculated for us. It's exactly what we calculated for ourselves and drew. So this is a correct graph that we drew. Now let's go to the next question. Question number 3 says, sketch the graph of g of x equals to minus half x squared minus 3. Mark the intercepts and the turning point. We're doing exactly the same thing that we just did. So we're starting with our a. Start with the a so that you can figure out what type of function you have. A equals to, increase the thickness. A equals to negative half, which is less than 0, so meaning that your graph looks down. It's a frowny face. Your graph looks down. So what is the turning point going to be? The turning point is 0q, which in this case is equals to 0, negative 3. It looks down. It has a turning point at 0, negative 3. Okay, what's the y-intercept? We make x 0. Therefore, y equals to minus half 0 all squared minus 3, which is equals to 0 minus 3. Therefore, the y-intercept is the point 0, negative 3. The x-intercept, we make y 0 to find the x-intercept. So therefore, that is equals to negative half x squared minus 3. Take the 3 to the left-hand side. You've got 3 equals to negative half x squared. Multiply both sides by negative 2. So you get rid of the fraction. So that becomes negative 6 on the left-hand side. And that becomes x squared on the right-hand side. Find the square root of both sides, that is plus or minus square root of negative 6 equals to x, which gives us an imaginary number. The square root of a negative number is an imaginary number. It's a non-real number. Now, if you're not sure how to get that, please go watch the video on the number system. You will figure out exactly how to determine whether a number is an imaginary number or what. So no real roots. So we do not have x intercepts in this one. So there are not real roots, so there are no x-intercept, which makes sense, and you'll see why it makes sense. Now let's plot these points on the Cartesian plane. We've got the turning point as 0, negative 3. 0, negative 3, it's the blue graph. 0, negative 3. 0, negative 3. That's where the blue graph sits. That's where the blue graph sits. Then we have our graph is looking down because our arms are facing down. Now what happens is that, let's figure out what happens at x is equals to 1. At x is equals to 1, y equals to, at x is equals to 1, y is equals to negative 1 half 1 all squared minus 3, which is equals to negative half minus 3. Take a lowest common denominator 2. That's negative 1 minus negative 6, minus 6, which is equals to negative 7 over 2. Negative 7 over 2 is simply negative 3.5. That goes for negative 1 as well. So negative 3.5 is when we have 1. Let's plot that point. Negative 3.5. Negative 3.5 is when we have 1. So that's where we put negative 3.5. Negative 3.5. And on the other side, negative 3.5 as well. Alright. Now let's see what happens when x is equals to 2. When x is equals to 2, when x is equals to 2, this is what we have as a scenario. 2 or negative 2 is going to give us the same thing, minus 3. So that is equals to negative 1/2 times 4 minus 3, which is equals to negative 2 minus 3, which is equals to negative 5. So on either side, when x is equals to 2, y equals to negative 5. When x is equals to 2, y equals to negative 5. That's the point there. That's the point right there. On the other side as well, when x is equals to negative 2, okay, let's fix this one. Let's fix that point. All right, now let's join the points. Let's join the points together. And that's what you have as a graph. Now let's draw the standard graph of a parabola, the y equals to x squared basic one, and see how it compares to this one. You don't have to draw this one. You don't have to draw this one at all. I'm drawing it so you can have perspective and you can be able to compare the two together and see how this one is different from the basic one. So that's 0, 1, 4, 1, 4. Then we've got 9. 9 is somewhere up there. Sorry. Let's draw this 4 on the right side, on the right place. Alright, now let's connect the dots. Let's join the points. And that's how the the points join together. And these are the graphs you're supposed to have. Let's see what the graph calculator drawn. It's exactly the same thing that we drew. Now moving on to example 4. The graph below shows a quadratic function with the following form: y equals to ax² plus q. 2 points on the parabola are shown. Point A, which is this point, the turning point of the parabola at 0, 4, and point B is at 2, 8 over 3. That's point B. Calculate the values of A and Q. Now, whenever you find a question like this, know that you will be dealing with a case of simultaneous equations. You've got two variables that you're looking to find, that is A and Q, and you've got two pieces of information that will help you set up a system of equations, two equations to be exact, and that is point A and point B. So we take that information and we use it to find A and Q. Now let's go back to our favorite color. We're dealing with y equals to ax² plus q. Y equals to ax² plus q. Y equals to ax² plus q. Ax² plus q. Alright, we've got the first point, 0.04 lies on y. Therefore, we substitute the points onto the equation. The y coordinate goes onto the space for y, and the x coordinate goes onto the space for x. So that's a in bracket 0 all squared plus q, and that's equation 1. That's our equation 1. Therefore, 4 equals to 0 plus q, meaning that therefore 4 equals to q, meaning that therefore y is equals to, for this point at this point in time, y equals to ax² plus 4. The other point 2, point B, which is 2 and 8 over 3. Okay, let's just confirm that. Yes, it's 2 and 8 over 3. Also lies on y. Therefore, let's substitute the points. 8 over 3 equals to a in brackets 2 all squared plus 4, because we already know what q is, so we write the equation with the complete q given to us. Now that is 8 over 3, take the 4 to the left hand side, minus 4 equals to a times 4. Now therefore, lowest common denominator is 3, so that's 8 minus 4 times 3 is equals to 12. And that is equals to 4a. 4a. 8 minus 12, take out a calculator. Don't try and do that with using your head, because that's how silly mistakes are made. 8 minus 12 gives us negative 4, so that's negative 4 over 3, which is equals to 4a. Now what you do is you divide both sides by 4. That's the same thing as multiplying by 1 over 4. So that's what you do. Multiply by 1 over 4 both sides, equals to 1 over 4 times 4a. Now they cancel out. 4 cancels with 4 and 4 cancels with 4. So on the left hand side, you're left with, therefore, minus 1 over 3 is equal to a. Meaning that therefore your equation y equals to negative 1 over 3 x² plus 4. And you've got your a and your q. Next question, example 5. Given the following graph, identify a function that matches each of the following equations. We've got f of x, we've got g of x, we've got h of x, and the last one is k of x. Now, if you look at this graph, now here are the equations that are given to us as options. You've got your 0,5x, you've got your x squared, you've got your 3x squared, and you've got your minus x squared. Now, the minus x squared is very easy to identify in this case because it matches the graph with the arms looking down, and that is k of x. So k of x matches with equation D, and that's what we write there. K of x matches with equation D, so we'll write equation D there. Now, on the other ones, the other three ones, basically it depends on how big your A is. If your big is the smallest, then it will have the widest shape. The widest shape. Then the one with the thinnest shape will have a biggest A. So let's start with the one with the widest shape. That's the one with the smallest A. That's 0,5 x squared. So that is going to be number A. H corresponds with number A. And the one with the thinnest shape corresponds with the A that is the biggest. So that is y equals to 3x squared. So that corresponds with C. And then the last one corresponds with B, which is y equals to x squared. And that's how you figure out which equation belongs to which graph. Now, next question. Two parabolas are drawn. G maps y equals to ax squared plus p. And then you've got your h equals to bx squared plus q. And you're given the graphs given to you like this. And the question is, find the values of a and p. The values of a and p belong to the graph G, which is the blue graph. So you go g of x is equals to ax squared plus p. Number A. G of x equals to ax squared plus p equals to ax squared plus p. Point we've got the point. Let's see what point belongs to G. Let's start with the turning point. Point 0, negative 9. Point 0, negative 9 lies on G. Therefore, we substitute. Negative 9 is on the y equals to a in bracket 0 all squared plus p, and that's equation 1. Therefore, negative 9 equals to 0 plus p, meaning that therefore negative 9 equals to p. Therefore, g of x equals to ax squared minus 9. Another point also lies on the graph. Let's see, we've got two more points that lie on the graph. Let's choose 4, 7. Point 4, 7 also lies on G. Therefore, 7 equals to a 4 squared minus 9. Take the negative 9 to the left hand side. 7 plus 9 equals to 16a. Therefore, 7 plus 9, take out a calculator. Don't try and add that with your head. I know you can do it, but let's avoid silly mistakes. So that's 16 equals to 16a. Divide both sides by 16 and you get 1 equals to a. Therefore, g of x equals to x squared minus 9. You've got your g and you've got your p and you've got your a. Number B. Find the values of B and Q with H. Find the values of B and Q. So H of x equals to bx squared plus Q. H of x equals to bx squared plus 2Q. So bx squared plus Q. Let's see what point lies on H here. Let's start with the turning point. The point 0.23 lies on H. Point 0.23 lies on H. Therefore, we substitute 23 equals to B 0 all squared plus Q, and that is equation 1. Therefore, 23 equals to Q, meaning that therefore H of x equals to bx squared plus 23. Alright, point, the other point, you can use 4.7, but you can also use the other one. Let's use the other one. Negative 4.7. Point negative 4.7 also lies on H. Point negative 4.7 lies on H. Therefore, 7 equals to B in brackets negative 4 all squared plus 23. Take the 23 to the left hand side. 7 minus 23 equals to 16B. Therefore, take out a calculator. 7 minus 23, that is equals to negative 16, equals to 16B. Divide both sides by negative 16. You get, divide both sides by 16, you get therefore negative 1 is equals to B. Therefore, H of x equals to negative x squared plus 23. And you've got your variables. Number C. Number C goes, find the values of x for which g of x is greater than or equals to h of x. For which g of x is greater than or equals to h of x. Values where your g lies on top of your h. These are the values. 4, 7, x equals to 4 and greater than 4, and to the left of negative 4. That's where the graph of g lies on top of the graph of h. That's how you figure that one out. X is greater than or equals to 4, or x is less than or equals to negative 4. Those are the values of x. Number D. For what values of x is g of x increasing? For what values of x is g of x increasing? G of x is increasing when? Let's take it from the left hand side to the right hand side. That's how you figure out whether a function is increasing or decreasing. Now notice that from the left to the right, your g is decreasing. However, once you get to 0 to all the way to the right, which is positive, your g is increasing. So which values of x is g increasing? That is x is greater than 0. X is greater than 0. Or you can write equals to, that's okay. X is greater than or equals to 0 also is applicable. Well, we've come to the end of this video. Thank you so much for watching. See you in the next one. Bye.